Welcome to the deep dive, learner. Um, what if I told you that the optimal tax policy for our future economy might not be designed by, a politician or some Nobel laureate,
Right. It might actually be designed by millions of AI agents playing what is essentially a massive high-stakes game of SimCity.
which is just wild to think about. But we are looking at a stack of incredibly fascinating sources today. We've got this detailed playbook on creating an AI economist, backed by academic papers from the National Bureau of Economic Research and the American Economic Association.
Yeah, we also have Anthropic's own performance studies, plus some really revealing 2026 reviews from the IMF.
Exactly. And, traditionally doing serious economic research felt a bit like, well, like building a cathedral by hand.
Oh, absolutely.
You had an ocean of coffee, a highly specialized team, and you'd spend weeks just pulling data from the Fed, right? Cleaning it, running econometrics models, all before you even got a single actual insight.
It was a massive logistical undertaking. You were just laying bricks for months. But the documentation we're looking at today tracks a massive shift.
Right.
Because we aren't just talking about a chatbot that writes a little snippet of Python code for you anymore. We are talking about autonomous agents.
Okay, let's unpack this. Because agentic AI is, it's one of those terms that gets thrown around a lot right now.
It really does.
So the actual mission of today's deep dive is to show you how anyone can build their own personalized AI economist. But to do that, we kind of need to understand the underlying mechanics first.
Yeah, we have to look at the 2025 and 2026 advancements, specifically things like Anthropic's Claude Code, which effectively hand researchers the heavy machinery.
Right, because a traditional large language model always felt to me like a brilliant brain in a jar.
That's a great way to put it.
Like it can answer your questions all day, but it has no hands. It can't actually do anything in the real world.
Exactly, and that is the perfect way to visualize the leap in this underlying technology. Agentic AI gives that brain hands.
It gives it hands.
Right. You can actually grab the mouse, open a terminal on your computer, and write the code itself.
Yeah.
In the past, you asked an AI a question, and it generated text. It was totally passive.
Yeah.
But Claude Code operates using what developers are calling vibe coding.
Coding. I love that term.
Right. It sounds so casual. But you basically program it using natural language,
Right.
literally just typing out your intent in plain English, and it translates that intent into terminal commands.
So it acts as an autonomous developer.
Exactly. It can read entire code bases, plan multi-file changes, execute tests, debug its own errors, and actually control a computer to build complete research tools.
I mean, I'm fascinated by the mechanics of vibe coding. It sounds so relaxed, but the reality is incredibly complex.
It really is.
Like Anthropic did an analysis of 100,000 real conversations, and they found that Claude Code accelerates complex tasks by up to 80%.
Yeah, the speed increase is just massive.
Yeah. And on the SWE benchmark in 2026, it hit an 80% score, which, for those who aren't software engineers, SWE bench is basically the gold standard for testing AI.
Yeah.
But it's not a multiple choice test, right?
Oh, far from it. SWE Bench consists of actual real-world software issues pulled directly from GitHub.
Oh, wow. Okay.
Yeah, so to score well, the AI has to autonomously clone a broken code repository, read through thousands of lines of code to find the bug, write the fix, run the tests, and push the update.
Without a human ever stepping in.
Without a human doing anything. Hitting 80% on that benchmark means it resolves 8 out of 10 complex, multi-step engineering problems completely on its own.
That is that drastically changes the barrier to entry. You no longer need a PhD in computer science to orchestrate these workflows. You don't just ask it a question anymore. You give it an objective.
Precisely. In Anton Korenek's 2025 paper, it's called AI Agents for Economic Research. He explains why this matters so much for the field of economics specifically.
Right. What does he say?
Well, he points out that this shift allows researchers, and really anyone analyzing data, to orchestrate incredibly complex workflows without deep programming expertise. It fundamentally changes the velocity of research.
Velocity.
Yeah. Testing an economic hypothesis used to take weeks of formatting data. Now, because the AI can handle the coding and the data cleaning autonomously, that friction is just gone. It takes an afternoon.
Okay, so the speed is there, the autonomy is there, the hands are attached to the jar. But how do we actually put this to work? Let's move from the theory to the practical application.
Let's do it.
How do you and I actually build this personalized AI assistant? The playbook calls it EconoClaude, right?
Yeah, EconoClaude. So the setup requires a Claude Pro or Max account, which gives you access to the computer use feature the literal hands we just talked about.
Got it.
You install the Claude Code command line interface on your machine, and then you provided access to key data APIs.
Which would be what exactly?
The big ones for economics are FRA, that's the Federal Reserve Economic Data, and the World Bank.
Okay, and the sources provide this hilarious but highly specific starting prompt to get Claude up and running.
Oh yeah, the persona prompt.
Right. You basically tell the AI, and I'm paraphrasing here, act as an agentic chief economist. Your name is Claude. You are precise, sarcastic when data is noisy, and always cite sources.
Yeah.
You are literally programming its personality alongside its technical parameters. I assume setting that persona isn't just for entertainment, though.
No, actually, setting that persona is a documented best practice.
Really?
Yeah, it acts as a system-level constraint. It guides the model's output style and forces it to prioritize rigor.
That makes sense.
Once the persona is set, the core mechanism of the agent is this loop. It's the think, act, observe, respond loop.
Okay, break that down for me. So if I ask Claude, like, how is the U.S. labor market doing right now? Oh, it can't just guess based on old training data, right? It has to actually go fetch the current numbers.
Exactly. First, the agent thinks. It processes your natural language and deduces, okay, to answer a question about the labor market, I need the current unemployment rate, which is the UN rate series on the Federal Reserve database.
Right.
Next, it acts. It writes a Python script to call the FRA API and literally executes that script on your computer.
Wow.
Then it observes. It looks at the data it just pulled back. Let's say it sees 4.1% for June 2025.
Okay.
And finally, it responds. It gives you a natural language summary, generates a chart using a graphing library, and maybe adds a sarcastic comment if the month-over-month data is erratic, just like you programmed it to.
That is incredible. So our agent can fetch data. But if we want to promote Claude to, say, a senior analyst, we need it to do the heavy lifting.
Right.
The playbook notes that you can have it run regressions, like ordinary least squares or difference in differences.
Yeah, exactly.
And for those who haven't opened a statistics textbook recently, difference in differences is basically a clever mathematical trick to prove cause and effect using observational data.
Right, like comparing employment in a state that raised the minimum wage against a neighboring state that didn't, and tracking that difference over time.
Exactly. And Claude is doing this using standard Python coding library.
Yeah. It imports a library like stats models, which is the industry standard toolkit for Python programmers to run statistical tests, or it uses PullP for complex optimization problems.
Wow.
The sources even detail how it can build these McKinsey-style financial models with base, bull, and bear scenarios.
Just automatically.
Yes. It can calculate the internal rate of return, the IRR, which tells you how profitable an investment is over time, and run sensitivity analysis to see how changing one variable impacts the whole model, all in minutes.
Okay, I have to push back here, though.
Sure.
We know large language models are notoriously bad at math.
They are.
They predict the most likely next word. They don't actually calculate numbers. So isn't relying on an AI for a highly sensitive financial model incredibly dangerous?
Well, the key here is that it's outsourcing the math to a calculator.
What do you mean?
When you ask for a regression analysis, the AI doesn't try to guess the statistical output in its own neural network. That would be a disaster.
Right.
Instead, it writes a Python script, opens a local tool like a Jupyter notebook, feeds the actual raw data into actual statistical software, runs the program, and then reads the output.
Ah, okay.
It validates the numbers through external deterministic tools.
Okay, so it's outsourcing to a calculator. But it still has to write the Python script flawlessly to feed the data in, right?
Yes, it does.
If it hallucinates a single variable in the code, or, I don't know, misaligns the columns of data, the calculator is going to give us a confidently wrong answer. How does it catch that?
That is exactly where the observe phase of that loop is critical. If it writes a flawed script, the statistical software will throw an error.
Right, it'll just crash.
Exactly. The agent reads that error log, realizes its mistake, rewrites the code, and tries again until the script compiles perfectly. It self-corrects based on environmental feedback.
Okay, here's where it gets really interesting. If one agent can run regressions and iteratively debug its own code, what happens when you string multiple specialized agents together?
Oh, that's when things get wild.
Right. We are moving from a solo intern to an entire boutique consulting firm.
You use frameworks like LangGraph or Claude Code's native scheduled tasks, the loop function. LangGraph essentially lets you create a flowchart of AI agents, where the output of one agent automatically triggers the input of the next.
So you build a team of sub-agents.
Exactly. You break down the workflow.
So you'd have, like, Agente 1, whose only job is the literature review. It scours academic databases, reads the latest papers, and summarizes the current consensus.
Right.
Then you have Agente 2, the data cruncher. It takes the parameters established by Agente 1, fetches the API data, and runs the econometrics we just talked about.
Yep. And then you might have Agente 3 running policy simulations based on those statistical models. Finally, you have an orchestrator agent that manages the other three, reviews their work to ensure it aligns with your original prompt, and compiles it all into a final polished report.
I love how this mirrors the real world. I mean, you wouldn't ask your hardcore quantitative data cruncher to also spend 3 weeks doing a qualitative literary deep dive.
Exactly.
Specialization makes the whole system smarter and more efficient.
And the real-world inspiration for this multi-agent approach is actually detailed in the sources, specifically Salesforce's the AI Economist project.
Oh, right.
They published the initial findings in Science Advances back in 2022, but the framework has been heavily updated since then. They used multi-agent reinforcement learning to simulate and design optimal tax policies.
Okay, wait, how does multi-agent reinforcement learning actually work in practice to design a tax policy? That sounds insane.
It's fascinating. Imagine a simulated economy. You program millions of AI subagents to act as citizens, workers, consumers, businesses. Their overarching goal is to maximize their own utility and wealth. Then, you introduce a central AI agent acting as the government.
Right.
Its goal is to design a tax policy that maximizes overall social welfare without crushing productivity. Through reinforcement learning, these agents interact millions of times.
So the citizens are actively trying to optimize their situations under whatever rules the government sets.
Exactly. The citizens figure out how to hide income, or they choose to work fewer hours if the tax rate gets too high, which drops the simulated GDP.
Oh, wow.
And then the government agent observes that drop in productivity and dynamically adjusts the tax brackets to close the loopholes and encourage work.
That is a wild concept. You're effectively crowdsourcing economic policy to algorithms that are trying to actively exploit the system.
Basically, yeah.
It's like a massive game of SimCity, but it allows the central agent to discover complex tax policies that human economists might never have thought of because it can run millions of permutations.
It allows these agents to independently discover optimal theoretical policies within simulated environments. Traditional economic modeling often relies on static assumptions about human behavior.
Right.
This multi-agent approach creates a dynamic ecosystem where policies are stress-tested against adaptive behavior.
But, okay, with all this immense power to simulate optimal taxes and run automated regressions, we have to pause. We have to look at the asterisks here.
Yeah, absolutely.
If we just blindly trust a multi-agent workflow, we are going to run into a wall. The sources dedicate a lot of time to the limitations, starting with the technical limits. Even in 2026, context windows. The amount of information the AI can hold in its working memory at one time, there's still bottlenecks for massive code bases.
Yeah, they really are.
If your project gets too sprawling, the AI can just lose track of the thread.
And forecasting is another major blind spot. The sources are very clear that LLMs are surprisingly weak at economic forecasting.
Really? Even with all that data?
Yeah, especially when you ask them to predict things beyond the cutoff date of their training data. Forecasting isn't just about reading the past. It's about anticipating structural breaks in the economy.
Oh, I see.
An LLM predicts the most likely next token based on historical language patterns. But if new technology disrupts a market or consumer behavior shifts drastically, the historical data won't necessarily predict the outcome.
The sources also cite a 2026 review from the IMF that found LLMs have a systematic optimistic bias, which is interesting. They struggle with open-ended questions that require deep contextual judgment. Why would an AI have an optimistic bias?
It really comes down to the training data. The internet, published papers, corporate reports, press releases, they all tend to frame things positive.
That makes sense.
The AI internalizes that bias. Furthermore, the IMF review highlights the golden rule of economics. Correlation does not equal causation.
Right.
LLMs are pattern-matching engines. They are incredible at finding correlations like, noticing that ice cream sales and shark attacks both go up in the summer.
Yeah, classic example.
But they struggle with true, robust causal inference. Actually understanding why something happened. and managing real-world uncertainty.
This brings up a concept I like to call the lazy supervisor.
Oh, yeah.
When you have a multi-agent system that can spit out a perfectly formatted 50-page economic analysis with charts, citations, and sensitivity analyses in 5 minutes, it is so tempting to just glance at the executive summary and say, looks good to me, ship it.
It's very tempting.
Because the output looks incredibly confident, so we assume the underlying logic is bulletproof.
That is exactly what the best practices section of the playbook warns against.
Yeah.
The mandate is simplicity first.
Right.
Don't build a complex multi-agent land graph system if a simple linear prompt will do. You must always require human verification.
You have to check the math.
You have to force the agent to show its step-by-step reasoning in its output, not just the final answer. And as we discussed with the calculator analogy, rely on external APIs rather than the model's internal memory.
Because if you don't audit the work, the consequences of applying a hallucinated tax policy or a flawed financial model to the real world are massive. These tools are force multipliers, not infallible oracles.
Exactly. But synthesizing all of this, the transformation of the workflow is undeniable. Building an AI economist radically reduces the time spent on repetitive tasks.
It does.
Scott Cunningham, who is a leading voice in the field and author of the book Causal Inference, he's actually cited in the sources noting that Claude Code radically changed his empirical workflow.
Wow.
It didn't replace his expertise, it removed the friction of executing his ideas.
Which really brings up the labor market impact. If someone is a junior data analyst right now and their main job is cleaning spreadsheets and running basic regressions, they might be looking at Claude and feeling pretty nervous.
Sure.
But the consensus in the sources is that while this technology might disrupt those junior execution-heavy roles, it actually shifts the value of human skill.
It elevates them, really.
Right. The premium is no longer on raw coding ability or data formatting. The premium shifts toward experimental design, formulating the right questions, and deep critical thinking.
You aren't just laying the bricks anymore. You have to be the architect.
Exactly.
You are managing the hyperactive intern. You have to know what instructions to give, and you have to know how to spot when the intern is confidently wrong.
So, to you listening right now, thinking about your own workflow, what economic task in your life or work would you automate first?
It's a great question.
Would you have it summarize the morning market reports? Build a budget model. It's incredibly accessible now. And remember, as the playbook says, your first failed AI agent is just part of the fun learning curve.
Definitely. And, as these multi-agent systems like Salesforce's AI economists get better and better, let's say they eventually become functionally flawless at crunching the data.
Okay.
They can simulate a billion scenarios and find the mathematically optimal economic policy to maximize GDP and minimize inequality.
Right.
If we reach that point, does that actually solve our problems?
Oh, that's a profound question.
Or will it simply reveal that our biggest economic debates about taxes, about welfare, about growth, were never actually about the math or the data at all?
Wow.
Will it reveal that those debates are fundamentally about human values and what kind of society we actually want to live in,